Amazing. Hi, everybody. Welcome to this week's Digital Making at Home live stream. It's great to see you all here. Thanks for joining us. I'm Mr. C, and I'm coming to you live from Cambridge in the United Kingdom. As always, I am here with the amazing and irreplaceable Christina. How are you, Christina? You good?
I'm good. It's so good to see you, Mr. C. Hello to all of our friends joining us. I'm Christina, and I'm in Nebraska, USA. Mr. C and I are part of the Raspberry Pi Foundation, and we're happy to have you all here with us today. Please say hi in the chat and let us know where in the world you are joining us from. I'm seeing folks already. I see, Desora, I see your comment on YouTube saying this looks promising. Yeah, we're really excited about today's show. We are broadcasting live to YouTube, Facebook, Twitter, and Twitch right now. And we'll be able to see your comments. Now, if you're watching on raspberrypi.org, you can click the title of this video to head over to YouTube to join the chat. So seeing Desori, hello from the UK, from London. Seeing comments coming in. Hi from the USA, from Kandahar. I think I'm saying your name correctly.
I love how international we are now, Christina. I love how international we are with our new time zone. It's so good. So for those of you who are new and joining us from our new time zone, Digital Making at Home is all about getting young people just like you, coding, creating, making things with technology. Every week, we chat with awesome people. Like this week, we have a really amazing guest. We'll get to that in a sec. We code together. We see amazing digital making products that other people around the world, young people just like you, have made.
Yes. Oh gosh, seeing Austria, San Francisco, the Czech Republic, Basim on Facebook joining from Iraq. Thank you so much for joining and welcome. So I'm really excited about today's stream because we are talking about machine learning. Now, in the simplest of terms, machine learning means that a computer program improves through experience. So when I think about that, I'm thinking of like voice recognition, like on my phone, maybe like Siri or Alexa. I have one, so I have to say it, I have to whisper it. How about you, Mr. C? Yeah, what do you think of when you think of machine learning?
A few different things, right? Like I love the idea that like machine learning is a computer just toiling away, learning new things by itself, right? You say, hey, go learn this thing, and you just let it go, and it like creates a thing. Like one of my favorite examples that I've ever seen of that is the walking robot. So Google this video we've got here. So this robot taught itself to walk. So it's a bipedal sort of looking robot. It's a complete simulation, but it taught itself to walk by moving its legs and trying to move as quickly and as efficiently as it could. You see it face plant there as it tries to mount a hurdle. Here it goes through leaps to cover the gaps. So the computer
looks like me at the end of a marathon.
yeah. I was going to say at the end of something else for a minute there, but yeah, no, definitely at the end of a marathon, you would probably like walking like that. One of your legs is like super knackered, definitely. But that's the weird thing about it, right? So the robot goes away and it teaches itself without you having to do a lot of input. And there are a bunch of things in our lives like that. Like you might have a smart thermostat in your house, like, you know, that they do that. They recognize your patterns during the day and then they train themselves to turn your heating on and off. Right? It's a very simple version. There's like the voice recognition, like you say, in Alexa, and Chef Watson. Have you heard of Chef Watson?
No.
Oh man, IBM built this thing, right? And so like Watson AI, you give it an ingredient or two and it will go and scour thousands of recipes around the world and come back to you with like options you can use for the things you have in your pantry. Very cool.
I need that. And now I appreciate the name Chef Watson. That's pretty cool. Oh, I love that. Oh, that's super neat. And then and we're also seeing more folks coming in from Russia, South Wales, Alex, Puerto Rico, bienvenidos. Oh, I love it. Thanks so much to everyone joining us. This is super neat to see. So yeah, Mark, we have someone who is studying machine learning. Who is our guest today?
Absolutely. Well, we've got Randy Williams with us today, and she's a PhD student at MIT, and she works with AI and robotics, and she's all about teaching young people about how to do those things. So bringing her on here is awesome because like I love learning about it. So I'm quite excited for us to learn about it today with Randy.
Yes, well, let's bring her on. Hi, Randy.
Hi.
Welcome. How are you doing today?
I'm pretty good. Coming live from Cambridge, USA.
That's I think the first time we've done that. That's super neat. Well, Randy, thanks so much for joining us. It's so great to see you. And we really appreciate you bringing your expertise. Because like I said, I tried to say, how did I do? In simplest of terms, machine learning. How did I do?
I think that was a solid definition. I love it.
Learning to do new things. Sorry, Randy, what did you say?
I say, machine learning. Computers learning to do new things.
How did you get into that? Like, have you always wanted to work with like computers and like, you know, high level computing? Because machine learning is quite complex computing. Like, was there a route to it for you from being a kid, or did you sort of, you know, pick it up at university?
Yeah, so for me, I totally like stumbled into it accidentally. So at first, I was really interested in fixing computers. It was something that my dad had me and my sisters do. As we were growing up, he'd take us to different places and help repair computers. And so I thought, oh, that's what computer science is, fixing computers. So I went to high school and I took a computer science class, and it was programming. And I was like, whoa, this is completely different. And then when I was in college or university, I chose computer engineering as my major because I still liked building things with my hands, but I also really liked this new programming thing. And I ended up working in a research lab that uses machine learning to help people with different abilities. So in this case, they were paralyzed sometimes in their arms and legs, and we would use machine learning to build new hardware interfaces for them. So for example, if you're in your house, but you can't move your arms and legs as freely, then maybe instead of using a remote to turn on a TV or using a light switch on the wall, you want to just gesture over something on your chair, like a little like hoverboard. And so we use machine learning to create personalized things like that so that people could be more independent. And then, yeah, it became a passion.
Very cool. I love that.
That's really neat, especially the piece you mentioned around thinking about it as fixing computers and then actually being introduced to programming in high school. And I think that's such an important thing, like computers and like what it means to engage with computer science is such, there's so many different parts of it, right? And that's really cool. I love that it was a part of like your family experience, like with your dad and your sister. That's super cool.
That's awesome, yeah. And so you're at MIT, which is the Michigan Institute of Technology, is that right? I'm Australian living in England, man. Like,
yeah, it's funny. I often have to have this conversation with my grandma too. It's Massachusetts Institute of Technology. And this lovely picture here is my building. It's called the Media Lab at MIT. And it's kind of a weird place, you know, never seen anything like it. But pretty much it's a group of people who love art and technology and science. And we all come together and we make amazing fun things in a nutshell.
That's wicked. And so is it the Institute of Technology? So is it all just tech? Like it's solid technology, everyone's doing sort of working on that sort of thing? Do you have any physicists and chemists or?
No, so technology, you know, the simplest definition of technology is it's any tool that you use to make your life easier. So this pen here, totally technology. But I think, you know, the way that we think of it now, it's usually computers, but there has to be a lot more that goes into it. Like there's lots of art that goes into it. There's lots of talking to people that goes into it, despite the stereotypes you might see on TV of like a hacker, like a computer, just like in the dark. Yeah, it's totally not like that. Definitely have to interact with people and be creative.
Yeah, and I've heard there's just such a range of studies there. Actually, I just spent a good amount of time with a former student of mine working on the MIT undergrad application. So fingers crossed she gets in, and she really wants to go there and study technology, but specifically in education and how it's impacting students at both like the intermediate, middle school, and high school level. So shout out to my student. Hopefully she gets in.
Because you've done that, right, Randy? You used AI and robotics as a platform to teach literacy and emotional well-being with young people. Is that right? Did I get that wrong?
That is exactly right. So as a PhD student, I do research and I work in a lab that focuses on making social robots. So if you think robot, you're probably thinking like, oh, it'll, I don't know, like wash the dishes for me or clean my house. But we build social robots that can use AI algorithms to interact socially. So this is an example. This is Jibo. And right now we're using Jibo to help kindergartners play games that teach them how to read and write and tell stories. Yeah.
That's super cool. So what are we looking at in that picture? If we just pull that picture back up again, what exactly is the rig that we're looking at in that photo?
Yeah, so Jibo is the robot on the left. In hindsight, I could have totally like shown a video. You can look him up. But he has the personality of a 10-year-old boy, and he's super hilarious. And on the right is a tablet that, if we're a student, then we'll be sitting in front of Jibo like this, and maybe we're reading a story together. Maybe we're creating a story about what's happening in this picture with the kitchen and the little boy eating a sandwich and things like that. And maybe Jibo's asking us questions like, okay, what do you see here? what do you call that red thing in the corner? So we can practice some vocabulary and things like that.
That's neat. Yeah. And
Have you done any work with Jivo and kids on the autism spectrum? Do you find that that's a really useful tool?
Yeah, so we use Jivo for a number of reasons. On one side, there are some children who just prefer to learn in different ways than others. So maybe children on the autism spectrum sometimes really take to Jivo because he's, kind of cute and kind of simple, and he tells very terrible jokes, and that all kind of draws them into wanting to spend more time with them. On the other hand, in Cambridge and Boston, which is another city right next to Cambridge, there are a lot of people who come from all different places in the world. And right now in the US, preschool isn't mandatory. And so some students will come into kindergarten and like, okay, we're going to learn how to read. But at home, maybe they speak a different language. And so they're not all at the same level. And so Jivo is a tool that we can use to help students practice their reading and writing skills, even if they maybe don't have an adult at home that can help them.
That's cool.
That's really neat. And I actually see some young people saying hi in the chat. Oh, I just lost it. But I think it was, where is it? Oh, I think Parsa. So yeah, Parsa in Colorado is 8 years old, saying hello. Thanks so much for joining us, Parsa. And let us know if you have any questions for Randy about machine learning or her robots.
Definitely. Yeah. Speaking of robots, like you teach AI and robotics to young people, right?
Yeah. So what happened was we were doing lots of studies with kindergartners and showing them our robot. And they're like, okay, well, we'd say, okay, here's how you set it up. And they're like, oh, no, I got this. I have an Alexa at home. I'm an expert. And we're like, okay, like go for it.
Makes sense.
Yeah, right? I'm like, you know more than me. And so there's this funny thing where when I was growing up, I learned about the internet as I already knew how to read and write. I was learning how to type. And that's kind of how it went. But now with like voice assistants, you can use the internet if you can talk. And so much younger kids are able to like interact with AI and able to search the internet. But then I would ask them questions like, okay, so how do you think this works? And they're like, oh, Alexa is my best friend. And I'm like, okay, like talk to this Alexa. And they're like, oh, this Alexa is a different color than the one that I have at home. So I have to get to know her. And I was like, oh, it's not quite how it works. So I started a project around teaching 5-year-olds, so same kindergartners, how AI works and how they can build it to do their own things instead of just using things that were already built for them.
Yeah, definitely. I love that problem-solving mindset, the idea of like providing young people a tool and saying like, what can you do with this thing? Because like kids are the most creative people in the world, right? Like, and if you can give them powerful tools and see what they can make, some of the stuff they do is like staggering. And I really love it. I love the idea as well when you describe the technology that you're using with machine learning and AI to sort of bridge that gap between like people and the world where there was one before. You're using AI to sort of counter that. Like you say, you can access anything now just by using your voice. Whereas before, you'd need to be able to type on a keyboard and a bunch of other stuff, have access to these things, and just very cool, Randy. It's the coolest thing. I love all of it. Like, it's so exciting. Very cool. And we teach, like, we do a lot of Scratch, right, Christina? Like, I love Scratch. Scratch is my favorite coding platform, like, far and away, because I can do ridiculous things with it. Like, why do you guys at MIT use Scratch? Like, what is it about the platform?
Oh, that's a great question. And I probably should have mentioned in the Media Lab, Scratch was invented there. So the whole Scratch team, they're right down the hallway. And I'm like, oh, that's them. But yeah, I think it's really powerful, because it's really popular. So a lot of people already know how to use it. And so if you want to teach someone something new, it's just always good to start from something that's familiar. And the other thing is it's just really fun and easy to get started. You click on blocks, things are flying all around your stage, and it's exciting. So yeah, I just think it's a great way to have people not get intimidated by AI and thinking it's something that it's too complicated or that they can't do. Like, of course you can do it.
Yeah, totally. I love that about it. Like, I think that's my favorite thing about using Scratch with Teachable Machine is because, like you say, it is so easy. And like knowing Scratch already, like young people, like the 2 boys in my house are 7 and 9, and I could throw them in front of Scratch. And if I give them the tool of Teachable Machine and say, this will follow your face if you set it up to do it this way, and then let them loose, they can make that amazingly powerful too, do ridiculous things in no amount of time. Like, I think that's really cool. And I think we should show some of the young people at home exactly how to do that, right? Let's build a teachable machine for them now. Like we can do it in no time at all. Yeah.
Yes, let's do some coding.
All right, cool. I'll share my screen. Okay, cool. So Teachable Machine, guys, this is Google's sort of AI that you can feed new things and it will learn. It does the machine learning part for you. And we're going to feed it some images today. We're going to build what's called a library of images, and we're going to use that to sort of inform our Scratch project. So you can get to that by going to teachablemachine.withgoogle.com, and we'll click Get Started. We'll open that one up. And we'll also need to open a special Scratch project up, everybody. So that's here. You can get to that. There's a short link that's coming up on the screen. And you'll be able to get to this Scratch project by going to rpf.io/ml-scratch. And this is a special project. I mean, I'll let Randy explain it. What's different about this version of Scratch that we're looking at?
Yes, so this is a part of one of my projects called How to Train Your Robot. And in it, I have students program a little tiny robot. And they learn all about machine learning algorithms like image recognition and text classification and the ethics behind all the algorithms that they're doing. So it's almost like Scratch, but it's a forked version. So there's something called open source software where the wonderful people on the Scratch team made it possible for other programmers to build on top of what they made.
Very cool.
For free.
We've got a really cool extension. So we've got the microbit one that's on here, which is pretty cool. The Teachable Machine is the one we're using today, isn't it?
Yes.
Cool. So I'll open that in my Scratch, and we come to.
I'm seeing folks in the chat asking if you can put up that link again. So let's go ahead and put up that. We've got this link here for the Scratch project, and then we've also got the Teachable Machine link. So grab those if you're going to be coding with us. But also know that this is recorded and it will be posted. This show, the live stream, will be posted on rpf.io/home. So you can always come back.
Okay, we're going to put it in the chat. The link will be in the chat as well, guys, so you should be able to follow it there any minute now. So you can see here there's all these different blocks that we're going to be using with Teachable Machine. And so until we have a model trained, there's kind of no point in building a script, right, Randy? Should we go across to Teachable Machine?
Yeah.
And...
Let's do that model first.
Sweet. Okay. So we're doing an image project.
Yep.
And then I have to gather samples. So make or add some samples here or watch the how-to video. Well, I've got a pro, so I don't need the video. So I'll just click web. So I need samples, right? I use three things that I can use. You guys can't. You can see all the toys behind me, right? But you can't see the desk in front of me is also filled with toys. 1 and 2. Ooh, my camera.
Little girl.
Oh no, I think Mr. C just froze. Oh, he's back.
I'm back. Did I freeze? Oh, okay, cool. My dragon. All right, so I want to use my webcam to train the model. Webcam. So if I click that, okay. So I'm going to hold my dragon in front of the camera.
Oh, it's a dragon.
Yes, it's a dragon. It's my daughter's plushie dragon. Okay, so I'm going to hold the dragon from outside, and I'm going to move in the picture as well. Whoa.
Oh, why are you moving it?
Well, I'm moving it to get all sides of the dragon, so I should be able to show it from anywhere. And I'm moving so that I don't train the machine on checking for me sitting in the corner rather than checking for the toy I'm holding. So that's actually really important. I'll train another model. So just one question, Randy. When I'm training these models, what sort of data makes good data?
Yes. So, I mean, I think moving is perfect because a lot of times when we think of machine learning and computers doing things, we're like, oh, it'll totally get it right, no matter what. But actually it learns what you told it, like literally exactly what you told it. So if you were only to hold your dragon facing front, it would think, oh, dragons only look like that. And if you're always holding your dragon and you're in the picture, then it's like, oh, dragon looks like this blue thing with your face next to it. And so, yeah, it's just like you're doing, it's important to give it nice, broad data.
Okay, so I've got 1, 2, oh, and I'll do my third. So what's that? I didn't do, which one did I do? Oh, I didn't do the teddy bear properly. I overwrote it, I think, or have I trained it really badly? Have I double trained it? I have, look, that's not good. So what I'll do is
Now, Randy, while Mr. C is doing that, I have a question. A lot of times I hear AI and machine learning used interchangeably. Is there a difference or are they the same thing? Help me understand.
That is such a good question. So AI is this huge bucket field for anytime you teach a computer, not just teach, but anytime you build a computer and have it do things that seem intelligent, kind of like the ways that we're intelligent. And so machine learning is one part of that. So machines can learn.
Okay, so it's under that umbrella.
Yeah.
Gotcha. Okay, that's really helpful.
But then there are other things like Jibo certainly has some machine learning, but the way that Jibo talks and communicates, its whole personality, like that's a different kind of AI that isn't really learning.
Oh, neat. Thank you. Thank you. I definitely appreciate it. I'm curious, as you've talked about machine learning, to be totally honest, before we connect, like I connected with you, I didn't realize how you could actually use machine learning to work in education. I thought that was such a cool thing to hear about the work that you're doing. And it sounds like there's just so many different types of people who are doing this work. And I'd love to learn a little bit more about like what I know you majored in, had an engineering degree, but how did you end up working with kids?
Yeah. So you're right. AI is used in many, many different fields. It's used in healthcare and business and science and policy and social justice. And for me personally, I thought, what do you want to be when you grow up? I have to choose one thing. I have to be an engineer. But on the side, I really loved like babysitting and working with kids. And when I got to university, I realized, wait, I can take this engineering thing that I love and apply it to all of these different areas. And some people went the other way. So in my lab, there's a whole bunch of different people, people with backgrounds in psychology and art, someone that used to be an animator at Disney. And they took what they loved and they applied it to the engineering thing so that our robots look nice and cute and stuff like that. So yeah, it turns out you can pretty much do anything and you can combine all these different skills and interests.
That's so neat. I think because for me, like when I felt like I had a really limited view when I went into college, like what you do with STEM or what you do with science. So to hear you say like, you know what, I love science. I also love kids. And for me, I did, and I ended up becoming a science teacher. And that was one of the best things I've ever done. But it's so cool to hear you getting a PhD and thinking about like, well, how can I use machine learning and that love of just working with kids, which is super neat. All right, how's it going, Mr. C? I
trained the model. So for those guys at home watching, I trained the model. So I click train the model here, and it goes through and it analyzes all my images, and then what happens, Randy? So it's analyzing my images for similarities and things like that, or
yeah, it's trying to find patterns that helps it distinguish one class, which is what each of those 3 buckets are called, from a different class.
Right. Okay. Cool. So it's looking for similarities and differences, I guess, then, and comparing and contrasting all the time. That's really amazing. And then so I train the model, it goes away and analyzes those pictures, and I can see it here checking my output down the bottom right. And it's sort of like it's detecting, so we can check to see if it's doing, so it knows there's a dragon's butt. Sorry, there we go. Dragon. 100% definitely that's the dragon. And if I take it away, it's what's really interesting to me too when I move. When I move, that tells me how well I moved during my training data, I think. Okay, and then we've got this one here.
Very sure that you're a hula girl.
Definitely. Yeah, it's pretty certain that I'm a hula girl. Yeah, it is. I think that's because of the red versus my red t-shirt. So maybe.
Yep, could be the pattern of the color.
All right. Still needs to hula girl. 100% dragon.
Nice.
That's cool. So that my model's working. I'm happy with how well that's working. Even though I still thinks I am 100% hula girl. I'll own it. I think that's pretty cool. I'll take it. Okay. So do I now export the model? Is that the last step?
That's the last step, to add it into the AI blocks /Scratch.
Yeah, cool. Okay, so upload for a shareable link, upload my model.
Yes, and it'll give you a nice personal link just for your model. So if you're following along at home, then you can do this all for free on the browser.
That's so cool. And so I go in here, and then this block here. So my top teachable machine block is the important one. I'll just shrink this down. Okay. And so this is where I put my machine learning link. So I just paste that in there. Cool. All right. So I've got this sprite called Danny. Right. So now that I've got my model trained, I need to build something here. So when green flag clicked, use model. Are there any other specific blocks I definitely have to put in at the beginning of my script, Randy, to make it work?
As long as your video is on and working, then that's about it. You can see right now next to Teachable Machine, it has that orange exclamation mark, which means it's not ready yet. But as soon as you hit the green flag, it will import your model and you'll get a green check mark.
Cool. And then so once it's imported my model, after that, it's basically, I use this one here when model detects class 1, which will still say class 1 because I haven't imported my model, right?
Right. Maybe
Right,
it's a good idea to import it then.
Okay, cool. I'll do that now. That's a good point. So we can see it. So I click green flag. And
Yeah, you can see your
There you
camera
go.
goes for a second. Off.
Very cool. And oh, look, it's changed my drop downs. All my drop downs are here. Okay, so when my model detects dragon, tell you what, I'm going to go when model detects dragon, and then I'm going to have it go say.
Mr. C, can you share again what you did to export the model?
Yeah,
We just have a question
sure.
from Arizu on YouTube.
Yeah, definitely. So back here when we were in Teachable Machine, you can see I've trained the model. So it all moves from left to right, like it's sequential. It's really nicely laid out. The UI is super duper intuitive. So you train your classes here on the left, and you move across to the middle part and train that model. Once you've trained the model with the button, you come across to export your model. Like I did that testing and showed you the toys, remember, Christina? Just to check down the bottom right in my output that it was happy. It still says I'm a hula girl, which I'm loving. Actually, it's growing on me. And then you just export your model up here. So once we export, we want that shareable link that we can paste into the Scratch block. That's the important part. And you upload, and then you'll get this link. So I've already got my URL, so I won't update my cloud model unless I change it. I don't need to. But yeah, I just copy that link and then paste it into my Scratch blocks.
Nice, thank you.
Yeah, super duper easy. Okay, so when model detects dragon, and then I'm just going to do this.
Nice. Duplicate.
Oh yeah, I always work smarter, not harder. Don't worry about that.
I'm seeing some folks who are just joining who are asking about the reference link, like the links that we use to get this. So we'll put those into the chat again, so you can check those out. Thanks so much for asking, Ramika on Facebook. I appreciate it.
Evan.
Okay. Let's see.
I love Scratch so much.
Nice. You can
All right,
see
hang on a second. I'll make it go full screen. And then,
Nice.
Hello.
and then.
All right, Babbage. Evan is my hero.
Oh. See, I'll take it away and we get hula again. So that's cool. Awesome. That's so cool. And that's a machine learning.
That's a machine learning. You taught your machine to recognize your toys. Yay!
Amazing.
We did it. We actually did it. And I think that, to me, when we first did this project, it was really neat to walk through this. It's such a great project to show kids and to bring into schools, like teachers can use this. Because what I loved is that it's simple. Like when I've heard machine learning, I'm like, I'm going to take a couple steps back. But now to see like, oh, okay, it is learning from experience. Like we gave a bunch of those images, we created our model, and then being able to put it in Scratch, it's a really fun way to explore machine learning for sure.
Yeah. And what's really fun is how creative students are with that. Like, so one of the schools that I worked at, they're right close to the river, and they were thinking about a beach cleanup. And so they trained their model to recognize like litter, like recycling litter from trash, from just things that I guess are supposed to be on the beach, like if a fish pops up or something. And then they could just go through and scan, and they wanted to make a robot that would automatically like collect all the litter and recycling and sort that out. And I love that. Like it's such a cool application of machine learning. And yeah, they were only in 5th grade. So if they can do that, then the doors are wide open.
Kids are amazing. And like you said, the kids who are like, oh yeah, I've used Alexa. I understand this. I know what the robots are, or even thinking creatively about how do we take this tool. I think that's so much fun that you get to work with young people. I want to be mindful of time. I'm curious for you, what advice do you have for a young person? I think doing research, especially getting a PhD, is a big commitment. Mm-hmm. Like how can a young person start to know and figure out like, is that something I want to do? Like I imagine there are kids who are seeing Randy, they're like, she's so cool. Like, how do I go into this? How can I work at MIT? How can I do this type of research? What advice would you have?
Yeah, I definitely think one thing that intimidated me was not learning everything like at the beginning. So everyone watching, like you're already way ahead because you're learning about this, and maybe you're like nowhere near a PhD. Like maybe you're still in elementary school. So good job, you're ahead of the game. And so I was always like, well, I didn't know what computer science was before I went to college, and I didn't know what AI was before I was almost in graduate school already. I didn't even know what graduate school was until I learned about it later on. But that's okay. I think just making sure that you're paying attention to yourself and your interests and what sounds exciting, and remembering that you really can go for anything. Which is not to say life isn't sometimes hard. Like everyone has different schedules, but if you hear about something and it sounds like fun, then learn more about it. You know, get excited about it, and don't ever feel like something isn't for you just because maybe you're newer to it. So yeah, I'd say keep an open mind.
Oh, I love that. Yeah. Thanks for being honest about like when you learned sort of about these things, right? Like folks might think like, oh, I need to know about graduate school, getting my PhD when I was a kid to be prepared. But for you to be honest and say, actually, like I learned about it later on, that actually gave me a lot of comfort. So thank you. I appreciate that. I'm seeing actually some questions in the chat. We've got one person asking, if you also trained a class of no toy, would it be more accurate or more confused?
Nice. That's a great question. I'm curious. What do you think, Mr. C? If you had made another class that's like just me.
I think the more data you can give a machine, the more accurate it will be able to predict things.
I think that's true, yeah. So if you want it to know something like that, then yeah, definitely train it. I've seen one student train every single card in a deck of cards, which kind of worked. So I definitely love that she pushed the limits and she wanted to see how far she could go with it. She got a little bit confused, but it could work. Yeah, the best way to learn is to try it out.
Because that's the similarity between the cards that's difficult for the AI, isn't it? So if you trained it with like 1 million pictures, would that be better for it, or would it take it longer to compute the answers for you? Do you know what I mean? Like, is there a point where your data set is too big or too full?
So what's cool about Teachable Machine is it's so small that you can train it really quickly, right? But of course, we have machine learning, for example, on our phones all over the place. Those machine learning algorithms have billions of examples of data, and then they're run on supercomputers for like a month, and then it's able to work super accurately after much trial and error and retrying. So I'd say you might have to experiment a little bit, but big real world machine learning models definitely use a lot more data than what we gave ours.
Awesome. That's really cool. I mean, thanks for coming in today, Randy. It was brilliant to chat with you. I love machine learning, and that was so edifying for me to come and chat to a pro, and really fun to teach you a machine. Thank you for coming.
That was an awesome project.
It's really cool. Yeah, I'm going to go share it with the boys later. I'm going to have them standing here. They'll be here for hours just holding toys in front of it to see what it does now. Amazing. Thank you.
I can't wait to hear about it.
Yeah.
Well, thank you so much, Randy.
Yeah.
It's so great to connect with you. Bye. Oh, thank you again, Randy. That was incredible. Yeah. Like machine learning is actually a lot easier than I thought it was, right? I thought it was going to be super complicated, but that was a lot of fun.
Definitely. But that's what's beautiful about Teachable Machine is that it's like a small AI that you can build in a very small amount of time. Like you saw, we did it in less than 10 minutes. We built an AI that could recognize 3 toys. And then what you do with that massively powerful tool, totally up to you. All right. The scratch part was simple. I put like 10 blocks in the project. The really cool part is having that massive brain in the cloud that you can then access and have it do awesome stuff with your simple code. So I recommend everybody go out, play with it now. If you want, we've got a special project for you guys that you can use specifically for anyone watching the stream. So only people who are watching now will get the link. If you go to rpf.io/vision-1, we've got a machine learning vision project for you to have a tinker with right now. It's got all the stuff there for you to have a play with. So head across now, exclusive just for this stream. And yeah, so it was great to see everybody getting involved, Christina. We had people from all over the world in the chat.
I know, yeah. Thank you to Tyeth on Twitch and Ramnika and Arazu, like all of these really great questions. I'm seeing folks excited to try this out with their kids at home. Thank you all so much for joining us. So that's all the time we have for this week, but you can always get in touch with us. Send us an email at dmah@raspberrypi.org. Let us know if you try the new project. We want to hear from you. And if you're a young digital maker interested in joining the stream, let us know. We have another live stream next week, same time, same place. Thank you all for being here for the Raspberry Pi Foundation's Digital Making at Home live stream. And I hope to see you next week. We're going to space. Until then, stay safe, healthy, and bye.
Catch you later, everyone.